Hola gente, Cinco de Mayo for me over here, ready to teach you guys about arc lengths and areas of sectors. So before we go there, we got to review some stuff, make sure that we're all good to go to be able to solve this question, okay? So first off, for a circle whose diameter is d and whose radius is r, here's how you find the circumference. Remember, when you're figuring out a circumference, it's like the crust of the pizza. It's measuring the outside of it. You can't just use a ruler because it's curvy, right? Pi times diameter is one way to do it, or 2 pi r. That makes sense because 2 radii make 1 diameter. Now, the area formula of a circle is doing pi times the radius squared. So, let's put all of this stuff to use. Which of the following is closest to the area of this circle? So, in order to do this, I would have to figure out, well, to find area, I need the pi times the radius squared. Well, I don't have the radius. I have the equation of the circle. Well, remember that this right here tells me my center, and this right here tells me my radius. So if the radius squared is 36, it means that the radius is 6. So I'd be doing pi times 6 squared. That's 36 pi. You would go ahead and throw that into your calculator and see what number is closest, and that would be 113. So that's answer 4. Okay. So let's keep going. Again, all just some review stuff before we get into the actual area of a sector questions. How many degrees make up a full rotation of a circle? 360 degrees. How many degrees are in the measure of arc AB? Arc AB is a diameter going through half of the circle, so that's going to be 180 degrees. What is the measure of angle ACB? So here's ACB. Technically, that's a central angle, so it would be congruent to the arc, or you realize that this is going through half the circle of diameter. It's 180 degrees also. What kind of angle is angle ACB? So we can call angle ACB a straight line, okay? Find the exact value of the circumference of this. So circumference is pi times the diameter, right? So the diameter, since they're telling me the radius, that's going to be here. So that's going to be 5 and 5 is 10. So pi times 10, I can call it 10 pi. And if you were doing 2 pi r, it's the same thing, right? Oh, I didn't write it straight. Straight angle. Now, since it says exact, you have to leave it like this. Because once you throw pi into that calculator, because it's an irrational number, it's going to give you a decimal. It's not going to stop this way, so you would have to round it. No rounding allowed. So that's why you're going to have to leave it as 10 pi. Then it wants to know what is the exact measure of length of the arc AB, right? Well, the arc is going to also now, here, is going to be the length of arc AB, 5 pi. Well, where am I getting 5 pi from? Well, if the circumference of the entire circle is 10 pi, then half of that would be 5 pi. All right? Keep all of this stuff in mind, kind of easy stuff, but it's all going to kind of tie together real soon. So a sector is a portion of a circle that is bounded or surrounded by 2 radii of an arc, and an arc. So let's take a look here. Here is your center. Now if I drew a radius here and a radius here, this is the arc that was created between those 2 radii, so this would be the sector. And if you see, it's surrounded by the 2 radii. One there, right there, and it keeps it in. It's a slice of pizza, okay? So as we said before, their circumference was the crust. The sector is 1 slice. So they are amazingly important in design, and there it is, pizza. So today we're going to look at finding exact area and arc length of a sector. So we're going to take a look at all of that stuff today. So here's our first example. In circle O, shown below, what is with a radius of 12, a sector has been defined by two radii, OB and OA, with a central angle of 60 degrees. This is known in geometry as the minor sector, created by the two radii. Okay, so this right here is the minor sector. Why do you think it's the word minor? Anybody? Because arc AB is minor. So you're using the minor arc, so it's a minor sector. Determine the circumference and area of circle O. Express your answer in terms of pi, the exact, and to the nearest hundredth. So define the circumference. We're going to do pi times diameter. So we're going to do pi times 24. Since the radius is 12, that means that the whole thing is going to be 24. So again, two answers. The exact in terms of pi answer would be 24 pi. Then you would go ahead and throw 24 pi into your calculator, and you would get the exact answer, which I did not do, so I'm going to have to grab a calculator and throw that in quick. And while I'm doing that, you can go ahead and we can find the area, which is going to be pi times r squared. And that is going to be pi times 12 squared. That's going to be 144 pi. So one answer here would be 144 pi. Now I'll take out my handy dandy phone and I'll put in 24 times pi, and I'm going to get 75.398. So I'm going to round that to 75.40. Then I'm going to go ahead and do 144 times pi, and I'm going to get 452.389, so I'm going to round that to 39. Saved myself there. All right, let's keep it going. What portion or fraction of the circle's area and circumference are contained in the shaded sector? All right, so what I want to know is what my daughter, who is in 2nd grade, is learning right now. Is what portion of this sector, or a fraction of this sector, is contained in this circle? Well, they gave me 60, and there is a total of 360. So 60 out of 360 is contained in that sector. Now, if you simplify that, you're going to get 1/6. Okay? So that's how you're going to figure out, okay, now since this was a central angle, that's how you know you're going to be able to kind of bound that out there. Determine the length of arc AB and the area of the sector AOB in terms of pi n to the nearest hundredth. Okay, I think I did that one. So now, let's start with the length. Do we know the entire length of the circle? Yes. The entire length of the circle, which is the circumference, is 24 pi. Now, I only want that small portion here. So what do you think I could do to that 24 pi to only give me this section here? Well, how much is that worth? It's worth 1/6. So you just multiply it by how much of it you have. 1/6 times 24 pi. And that's going to be 4 pi. So now that would be the answer in terms of pi. That's more of an exact answer. And then in terms of to the nearest tenth, 4 times pi, 12.566. So 12.57 would be the exact distance of AB. And you're going to do the same exact thing for area. For area, the entire circle is worth 144 pi. But I only want the area that's bounded by that 60 degrees. So then the exact answer would be 24 pi. And now I started to actually do some work, and it was 75.398. So it's 75.40. That would be the area of the sector. The length of the sector. Hopefully that all made sense, because if it did, then I did my job, and you'll find everything to be really easy. So it's the central angle that gives us that portion that we'd want to know, right? It's this guy here, whether you're going to find the arc length or the area of the sector. So this is the arc length right out here, and the area of the sector is this little piece of orange there. So now the formula would be, we'll write here, okay, arc length is equal to the angle divided by 360 times, now it's length, so you're just going to use the circumference formula, pi times diameter, or 2 pi r. Now the angle has to be the central angle. Okay, that's important. Area of a sector, same game. Area of the sector is the angle, which again has to be the central angle, and then you're going to use the area formula, which is pi r squared. All right, so let's do a couple of examples to see if we got, we know what we're doing here. So question number, or exercise 3. A patio in the shape of a circular sector has a radius of 20 and a central angle of 110. Find the area of the sector to the nearest square foot. Okay, so I want his area, so I'm thinking pi r squared in my head. Now I only want this area here that's bounded by the 110 degrees. So to do that, you're going to do its area, angle over 360, times pi times the radius squared. So the central angle they told me was 110 over 360 times pi times 20 squared. Now if you throw this guy right in here in parentheses, you just go ahead and throw that whole entire thing into your calculator. Why would I just throw the whole thing into that calculator? Because it said to the nearest foot. So I don't have to worry about it being a decimal or worry about having to put pi in my calculator. And then I would say it was 389.9 blah, 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 blah. 384 would be the square footage. All right? So that is finding the area of a sector. Next one. A garden has the shape of a circular sector such that its straight sides measure 50. And the length and the central angle is 132 degrees. If the garden needs to be surrounded by fencing, so here is my nice fence that I'm going to put up, how many feet are needed? So now this one is asking for a length. So I'm thinking, since it's circumference, I'm going to be using the pi times diameter. So it's angle over 360 times pi times diameter, or 2 pi r. Doesn't matter which one you're using. Now they told me the central angle is 132. Now here I'm not going to use 50 because I'm going to use 100 because this is technically this is the radius of the circle. So think this is the whole big circle right here. That's the whole big circle right there. So the radius is going to be 50, so the diameter is 100. So be careful. Again, they're asking me to round, so I can go ahead and throw this entire thing into my calculator. It's going to say 115.19, so I'm going to call it a cool 115. Okay? We're just rolling right along here. So this proportional relationship can also be used to solve for the central angle. Okay? So let's take a look at what that means. So this is saying, well, I'm going to give you everything else. I'll give you the answer, but I'm not going to tell you what angle I used. And shouldn't really feel too much different. It's just going to be different types of math that we're going to do. So a sector of a circle whose radius is 5. So let me draw a circle. I'll draw a sector. I don't really care what it looks like. The radius is 5, and it has an area of 20 square centimeters. So the area, not of the whole entire circle, but just this sector is 20. Is the central angle of this sector acute or obtuse? So we're looking to try and figure out what that central angle is. So now, since they said the area of the sector, that's the angle over 360 times pi r squared. Now they told me that the area of the sector was 20. They want me to figure out the angle, and they told me that the radius is 5. So I just set the whole thing up. Now we have to just do math. I'm going to start doing my math over here so I can fit it all. So it's 20 equals x over 360 times pi times 25. So the whole game here is to try to get this x by itself. So since I have multiplication here, I'll divide out the 25 pi like this. Okay? So you're going to have x over 360 equals 20 divided by 25 pi. Now, this gets a little bit ugly, so you'll just kind of try to put it one step at a time in your calculator. Key thing here is when you are putting this into your calculator, this denominator has to be in parentheses. So you're going to be doing 20 divided by parentheses 25 times pi. Then you hit equals, you'll get a big old ugly decimal. We're not even going to write it. Okay, so we're going to have a number right there. Then you're just going to multiply and take your calculator and hit times 360. Okay, this way you're not going to get too lost. You let the calculator do all of the work for you, and you're going to get a number like 91.67. Yeah. Now, is this angle acute or obtuse? So remember, if you are less than 90, you are acute. If you are more than 90, you are obtuse. So we're going to call you obtuse. All right, so with all that in mind, hit pause, try 6. A horse is attached to an 8-foot long rope, can rotate through a distance of 28 feet. What angle can the horse walk about? So I want to know, what is that angle right there? And now this is a length. So I am going to be using the circumference, okay, or the length of the sector, which is going to be x over 360, that's the central angle, times pi times diameter. So the length is 28, and the diameter is going to be 16 because the radius is 8. Do what we did before. Divide by the 16 pi. We also remember, because I just told you that this is going to be in your calculator in parentheses, or you're going to get the whole thing wrong. So you did 28 divided by, in parentheses, 16 pi. You hit equals, right? Then you're going to take that number and multiply it by 360. And then that is going to give you a number of 200.5, round it to the nearest degree, so we're going to call it 200 degrees. So there you go. There's working with areas of sectors and lengths of sectors. Hope that helps. Leave a comment to let me know if it is helping for you.